E, are rain and clouds mutually exclusive? It's A and B. A and B are mutually exclusive if the probability of A and B is equal to 0. Probability of A and B is not 0, it's 0.4. Right, so we say but probability of A and B equals 0.4, not 0, so A and B are not mutually exclusive. F, no clouds and rain mutually exclusive. No clouds will be B bar and A mutually exclusive. B bar and A are mutually exclusive if or only if probability of B bar and A is equal to 0. Alright, B bar and A, so let's go back to our table. So it, B bar and A, that element there is in fact 0. So they are mutually exclusive. Okay, so what are those two events? That was no clouds and rain. Right? That is, no clouds and rain cannot happen at the same time. By no clouds, we mean absolutely no clouds. Alright, G, are rain and clouds independent, A and B? Alright, so A and B are independent if probability of A and B is equal to the probability of A times the probability of B. Since we have a 0 in that table, that's not going to happen. Probability of A and B is 0.4. Probability of A and then the probability of B. Probability A is 0.4, B is 0.7. It's 0.28, alright. It's alright. It's not equal to 0.28, so A and B are dependent, or you can say not independent. So that was G. H. Alright, if the probability of rain on any day during a month is 0.4, and if the occurrence of rain on any day of that month is independent of rain on any other day that month, over a 5-day period, what is the probability of no rain on the first 4 days and rain on the last day? Okay, this is not a probability that we can answer from the table. This is a different probability, right? Rain on sequential days, and the table doesn't help us with sequential days. All right, so but we still have the probability of rain is 0.4, and they're independent. Okay, so we just multiply the probabilities together without worrying about the candy in a jar type situations. Independent means that it's like a coin toss. So we have the probability of no rain on the first 4, and then rain on the last. So the probability of no rain on the first 4, and then rain on the 5th day. Okay, so no rain complement is 0.6, And we'll have 4 of those, 4 days with no rain. 1, 2, 3, 4. And on the 5th day we have rain. It's 0.4. Alright, and I get that the answer to that is 0.05184. About a 5% probability of that happening. Okay. Alright, again, I want you to try this problem. Look at this information. I'll read it with you, sort of thing, and then I'll show you the questions below, and hopefully you can answer the question, and later on I will go over it. All right, a retailer is looking at past statistics to gain some insight into the chances of a good shopping holiday season this year. From all indications, there is a relationship, that means dependence, right, which is opposite of independence, of how good the revenue is on the day after Thanksgiving and how good the revenue is the rest of the holiday shopping season. In the past, 55% of the revenues on the day after Thanksgiving were good, while 60% of the revenues for the rest of the holiday season can be regarded as good. 1/3 of the days after Thanksgiving that were not classified as good were also followed by a holiday shopping season after Thanksgiving that were not classified as good. All right, find the following probabilities. All right, so what you might want to do is to pause this, identify your events, write down the probabilities for all those, and then look at the questions below. All right, and at this point, you can pause the video, look at the questions, do the questions the best you can, and then look at my answers.